Hello friends, today we will see non-cutting moves. Non-cutting moves are used for avoiding the collision between the part and the fixture and the part and the tool or holder. So we use non-cutting move. In non-cutting move, in engage or departure, we have when tool is engaging with the part or when after cutting tool is departing. So that time we can use this non-cutting move. So we have two type of condition. One is when we have the close area. If you will see in this figure in, so we will see here we have the close area. So we can define this non-cutting move for close area and for open area. So it is a different way to define close area and for open area. For close area, first we can assign helical move. Helical move we use for collision free first cutting motion when the tool path or tool is engaging with the part. So helical is this one. You can see the tool is coming in helical way and it is engaging in helical way before touching the top face of the part. And for ramp shapes, you can see the ramp shape. So for ramp engage, the tool will move like a ramp, and we can also control this value with the given parameter so that the tool will avoid to touch the top face of the part. Okay, so in plunging, tool will come directly and it will directly come and it will enter with plunge direction. So we need a specific height to avoid the collision, and the height must be greater than the material on the face. See, if you have any material on the face for facing, so height of this plunge direction or plunge value must be greater than the face material. None if you don't want to generate any engaged toolpath. So we can directly use this none and it will come and directly it will engage with the material. Right. So let us see this with example. So here you can see I have one part, and here this is a cavity mill, and in cavity mill you can see this part. So hide, show this, and make it wireframe. Here you can see this is engage. Double click here, and here in non-cutting we have engage, and engage if we are talking about the close area, so it is helical. So in helical manner it is engaging, and the engage arc is the diameter is 90% of tool. So tool dia is 30, right? So we can check it from here. If you want to reduce this to 50, select this and again generate. Minimum 65. The diameter of helical must be greater than or equal to the ramp length. So ramp length, we need ramp angle. So ramp angle will this one 15, and it will generate 15. And here is the minimum ramp length, which is 70. So I am selecting this 55, and here you can see this will change. If you want this 50, make it 50 or less than 50. Ramp length is this. See, now helical is properly visible, and the ramp length is from front view. This is a ramp length. Okay, see this from here to this is a ramp length. And helical the tool will go smoothly inside the material in the first cut. If you want to change the ramp angle, see this is a ramp angle, this one. So I want to change it to 5 and generate. Say this, if you will reduce the angle, the helical shape will increase, it will move a little bit more. So we can change this angle to reduce this helical shape. Okay, now next is ramp on shape, generate. The ramp shape will visible from the top, you can say here and then this, right? So this is the ramp shape, this one. For ramp shape, the ramp angle will come from this side. This is the ramp angle, it is 20 degree. I'm going to define this as 15 and see angle will reduce. And the height of this is 3 mm. And ramp angle, again ramp length is 50 from here to this, the ramp angle is this, ramp length is this 70%, and see this will increase. We use this for close area, these are the close area. And plunge, if you want, this will come directly with plunging. Here we have plunging. If we will see, say this is the plunge value, right? This is the plunge, now it is starting to cut. Okay, and none, the plunge value will not generate, plunge move will not generate, directly it will come and it will start to cut. Okay, and one more option, same as open. So if you have any open area, so we can also use this as an open area. So it means the value which we have mentioned for this open area, same will work for the close, right? Mostly case we use helical or ramp. So select this helical. Okay, or cancel it. Now come to this for open area. See, now we have some open area. So this is the tool path for open area. First, dark background. Here you can see the engage is here, this yellow one, engage value. So it is arc. In arc manner, it is the radius is 30%. This radius 30% of tool. I want 45. This arc will a little bit bigger. Now say this from top. And arc angle, so arc angle is 90. It is good to use this 90, don't change this. And then height, so height is this one. If you will see here, we have this height, this height is 1. If you want to change, you can change. Minimum clearance, minimum clearance is this complete value, 50% of tool dia. If you want to change to linear, so linear it will come, say this like, and generate. See, the linear direction will come, and the length is 90. The length is 90% of tool dia. Swing or ramp angle, so ramp angle I am defining from front. If you will see, it is horizontal right now. I am adding 15 degree as a ramp angle and generate. Okay, and swing angle again 15. Say this, here it is, and here, right? So ramp angle, keep this 0. This is 0, and from top still it is angle. Now keep this 0, generate. Now it is here, and from ramp angle add 15, generate, and it will generate, right? Here it is not properly visible. See, it is not properly visible from this direction, but you can see this thing in departure. In retract, see this, retract will be the same as engage, so it will also change. When we'll change this direction, this will also change. Keep this 0, and if you will generate, this will straight right now. Okay, and the height is this one, so I'm increasing to 3, generate, right? Here also 3. Now arc, now point, or we have different option for arc: normal to axis, normal to part, so point. So let's say this point, so I want to start from a point, but here we have 1 2 3 4, we have 3 2 2 engage area, so cancel it. And for this thing I am using one more geometry. Click this steep, and geometry, select this geometry, okay, and use the part and generate. See this, it is engage, and retract as this one. Okay, and come to this strategy, and from strategy I am using direct on part with mix and generate. So here I have only one engage and one departure, right? Now I want to add a point so that I can define. So come to this modeling, and from modeling add a datum plane. Okay, click here, draw a line, finish. So now I have 2 point. Again switch to manufacturing. This operation I will tell you in upcoming lecture, no problem. Now double click here and come to this engage. For this open area I am using point, so I want to start from this point. See, the point is defined. Now generate. Okay, the point is this one, same as open. If you will see, right, we can use this in one more different way. Just cancel it, double click here, and for point I am using this point. Now generate. So with respect to this plane it will generate a radius. Okay, and this will move and come. Okay, if it is coming outside, if it is starting from outside, then only this will possible, or we can use for different geometry. Click this, generate, and again engage, and for the point I'm using on face, the face point is this one, and the direction is y minus 25, where it is an inch minus 1. Still it is too far. Now the point is defined, and generate and see, right? It will start from that point only if the condition will fulfill. And for second, for retract, it is again coming to that point. Let's see. Say this tool is starting from here. It is cutting the tool, cutting the face, and after finishing the toolpath, again it is coming to this point. Okay, it will work only for the certain condition. If it is possible, then only it will use like this. So hope you understand this. And one more thing, avoidance. For avoidance, what we can do, see the toolpath is starting from here. I want to define from point. So tool will come from this point and generate. See, the tool is coming from this, and it will move from here to here and it will start. So this is the first point and start point. So I want to define start point from here, generate. This value will eliminate and directly it will come to this point which I have defined. Say this. But after retracting, the tool will not go to that point. So here we need to define return point, specify. Again, I want the same point. Pick this point, drag it to here, generate. Go home. Let's see first. No, it is not going back. Same as form and generate. Okay, it will come back. So hope you understand this, how to define this avoidance.